Hello everyone, my name is Inalio, and in this video I will present you my student performance prediction project using Python and machine learning. The objective of this project was to analyze a dataset containing student information and final grades in order to identify important relationships between variables and build predictive models. For this project, I mainly used Pandas, NumPy, Matplotlib, Seaprint, and scikit-learning. Pandas was used for data manipulation and data frame operation. Matplotlib and Seaborn were used for visualizations such as histograms, scatter plots, KDE plots, ECDF plots, and heat maps. Finally, scikit-learn was used for processing normalization, regressing models, pipelines, and evaluation matrix. I'll start with data exploration. So first I load the dataset using read CSV and displayed the first rows using it to better understand the structure of the dataset. The dataset contains 649 rows and 20 columns. Each row represents a student and the target variable is called grade, which represents the final student grade. Then I use info to examine the data types and detect missing value. Some columns contained missing values, especially age, study time, from real, health, absences, and G1. I also use Describe to generate descriptive statistics such as the mean, standard deviation, minimum values, and maximum values. After that, I created several visualizations. First, I created a histogram of final grades. Shows that the histogram shows that the most students obtained grades between 10 and 15, meaning that the majority achieved average academic performance. Then I created a scatter plot. The first scatter plot showed the relationships between G1 and the final grades. Students with higher G1 scores generally tended to achieve higher final grades. I also created a scatter plot between study time and final grades. This graph suggests that students who study more generally tend to obtain better grades. After that, I create a KDE plot and an ECDF plot to better analyze the distribution of grades. I also created group by reports to compare average grades according to gender and school. Finally, I analyzed the relationship between the absences and the final grades. The graph showed that students with many absences generally tend to achieve lower grades. After the exploration phase, I moved to processing. So first, I checked the missing values using isNull.sum. Then I converted categorical variables into numerical values because machine learning models require numerical inputs. For example, school, gender, parental status, and activities were converted into integers using customized mappings. I also converted parental education levels into numerical values. After that, I handled missing values using FailNA before model training. Next, I performed correlation analysis. The results showed that G1 and G2 and G1 were the features more strongly correlated with grade. Failures show that strong negative correlation, meaning that students with more failures generally achieved lower grades. I also created a heat map to visualize the relationships between the most correlated features. Then I moved to model development. First, I divided the dataset into X, which contain the independent variables, and Y, which contains the target variable, grade. Next, I normalize the features using min max scalar dot normalization scales the data between 0 and 1 and helps improve model performance. Then I created several machine learning models. The first model was a multiple linear regression model called LM1 using all normalized features. The second model was a simple linear regression model using only G2 because it was highly correlated with grade. Then I created another regression model called LM2 using the 5 most correlated features. I compared the model using R-squared scores and mean squared error values. Afterward, I performed a polynomial regression with degree 6. This model achieved a higher R2 score because it captured more complex relationships between variables. I also created a pipeline combining normalization, polynomial transformation, and linear regression into a single workflow. After model development, I moved to model evaluation. First, I performed a four-fold cross validation to evaluate model consistency. Then I split the dataset into training and testing sets using train test split with 30% of the data reserved to testing. I tried another linear regression model and evaluated its performance on the testing dataset. Next, I analyze the relationship between polynomial degree and R2 score. Finally, I trained the decisions tree and random forest models. The random forest model achieved the best overall performance because it combines multiple decision trees, improves accuracy, and reduces overfitting. So, in conclusion, this project demonstrated how machine learning and data analysis techniques can be used to predict student performance. The project include data exploration, processing, correlation analysis, and regression models, pipelines, cross-validation, and tree-based model. This project also helped me to better understand processing techniques, regressions models, normalization, pipelines, and machine learning evaluation methods. Sorry. So thank you for watching my presentation. I hope that I will have a good grade. Thank you.